All right, this is the sample test to Chapter 4, the first part of Chapter 4 on unit circle trigonometry. Realize we have a calculator and a no calculator part to this test, and we're going to start out with the calculator active part. So, in question number 1, it says find the value of the following truncated to 4 decimal places, and we need to find the secant of 3 pi over 7. First of all, realize that this angle is one thing, so it should be in parentheses wherever we put it in. And we have to know our relationship of our reciprocal function. We should realize that the secant of an angle is 1 over the cosine of an angle. This is important because we don't have a secant button on any of our calculators, really. When I turn on my calculator, I also need to realize that I need to be in radian mode. So whichever calculator you're in, just be sure your angle is set for radian mode. And we need to do 1 divided by the cosine. If it's TI, the parenthesis pops up. If it's Casio, you're going to have to type the parenthesis yourself. And it is 3 pi divided by 7. And there's my decimal version, 4.4939. Okay, in order to do part B, the cotangent of 163 degrees, I need to realize that the cotangent of an angle is 1 divided by the tangent of that angle. So to find the cotangent of 163, in my calculator, I'm going to have to go back to degree mode. So let me change my angle back here to degrees. And I need to do 1 divided by the tangent of 163. And that gives me negative 3.2708. Again, make sure you were truncating those to 4 places after the decimal. That means chop them. All right, let's go down to question number 2 here. It says Snowmass is a mountain in Colorado, great mountain ski, with 4,406 feet of vertical rise. That means you go up 4,406 feet. You're building a lift, a ski lift, to take the skiers from the base of the mountain to the top. So here's your ski lift that you're going to travel along the side of the mountain. The lift will span 9,400 feet up the side of the mountain. This is the straight line distance from the base to the peak. Question A says, what horizontal distance will the lift cover? So the horizontal distance is this distance down here. We know the vertical and the horizontal make a right angle. Since this is a right triangle, we can use the Pythagorean Theorem. I'm going to call this D for distance, and my 2 legs of my triangle are D and 4,406. So I'm going to square each of those, and when I add them together, that has to equal 9,400 squared. So I'm going to go to my calculator because these numbers are big. I have 9,400 squared. I'm going to subtract 4,406 squared to move that over to the other side. So now I have, that's what my d squared is equal to. And then in order to get my d by itself, I would want to take the square root of both sides of that equation. I don't have to worry about any plus or minus because I'm dealing with the distance here. I'm going to use the answer button so I don't have to type any of that stuff again. And I have my final answer of 8,303.442. And you know we like to give units with this, and all of our units in this problem dealt with feet. So that is my distance. All right, part B says, what angle in degrees will the lift make with the horizontal? So the lift and the horizontal is this little acute angle in here. I'm going to call that theta. So I could use part D that I just found, but I'd be more confident if I used the 2 parts of the triangle that were given to me. So the angle, or the side across from theta, would be the opposite side, and the lift was the hypotenuse over there. So using SOHCAHTOA, the 2 trig ratio that I have that involves the opposite and the hypotenuse would be the sine. The sine is the opposite over the hypotenuse. My opposite was 4,406. My hypotenuse was 9,400. So in this case, I'm trying to figure out what the angle is. So to get the angle by itself, I have to undo sine. What's the opposite of sine? It's the inverse sine of this fraction over here. I would just leave the fraction as is, not even bother to simplify it, because my calculator can do that for me. So I need to be in degree mode, which I already am. I need the inverse sine, which is the shift key and then the sign. And then I need to be sure that this is in parentheses. If you have a TI, the parenthesis pops up. If it has Casio, you type it. And we hit enter, and our angle is 27.9514 degrees. Remember that degrees are a unit of measure, and I need to put that little degree symbol there, or it would imply that my units were radians. All right, last question, number 3. A surveyor determines that the angle of elevation from the base of a tree to the top of a building is 57 degrees. So I'm going to have a tree. Here's my tree. I'm going to have a building. Here's my building. And the angle of elevation from the base of the tree to the top of the building, which would be this angle right here, is 57 degrees. The building is known to be 120 feet tall. So the height of the building is 120 feet. Determine the horizontal distance from the tree to the building. So this D is what I'm looking for right here. I know this is a right angle. Well, I hope it's a right angle when I'm dealing with a building. So what do I know? In relation to my angle, the 120 is the opposite or the across from the angle. The hypotenuse would be over here. I don't know anything about the hypotenuse, so I'm going to ignore that one. What I'm looking for is D, which is the adjacent. So which of my trig ratios deal with an opposite and an adjacent? That would be the tangent, or TOA from SOHCAHTOA. The tangent is the opposite over the adjacent. So let's fill in what I know. I know my angle there is 57 degrees. I know my opposite is 120, and I don't know what my adjacent is. I'm going to call it A. I think I called it D before, but it looks enough like an A. So I need to solve this. In order to solve that, I don't like my A on the bottom, so I would multiply to get the A to the other side. And then I would divide to get the tangent to the other side. So I have 120 divided by the tangent of 57. I'll just leave it like that so I have an exact answer, and then I'll go over to my calculator and type it in. Again, I need to be in degree mode, which I still am. 120 divided by the tangent of 57 is 77.9289, and my units for that would be feet, because all of the measurements I had in this problem dealt with feet. Okay, so now I'm turning the page, and that's going to take me on to the no calculator part of the test. So now we're dealing with some angles here. It says show all work for every problem and simplify your answers. Question 4 says graph and label the angle in standard position, keep the same angle units. That means if the problem's in radians, don't convert it to degrees. So my theta that I'm drawing is negative 7 pi over 12. In order to draw an angle in standard position, I start with the positive side on the x-axis over there. I need to turn in the negative direction, which means I'm turning clockwise, but I need to figure out where I'm going to stop. Remember that the y-axis is at half a pi, so I need to figure out, is 7/12, is that more or less than half a pi? Well, half a pi would be 6/12, so 7/12 is going to be a little further than that, and I can label that theta. So I've graphed it, I've labeled it, I made sure to have my arc showing the direction that I was spinning, and I made sure I was in standard position. Okay, so question 5, mark and label the reference angle and find its measure. Keep the same angle units, so we want to stay in degrees. If I'm trying to draw beta is 425 degrees, I'm going to start out in standard position. I'm going to spin counterclockwise. 360 degrees would get me back to there, so I've got to check out how much more do I have to go. 425 minus 360, well, that would be 65 degrees extra. So I'm going to go up here a little bit. There is my angle beta, and my reference angle would be this little amount here that I've gone over 360. So my reference angle, beta r, I'm going to call it, or beta prime, is 65 degrees. It has to be positive, acute. It has to be between the terminal side and between the x-axis. All right, number 6 says state the smallest positive angle in degrees that is coterminal with negative 530. Remember that coterminal angles start and end in the same place. That means they differ by a multiple of 360. So I could start with negative 530. I could either add or subtract 360 to get a coterminal angle. if I want to turn into a positive angle, I'm going to have to add 360. If I do negative 530 plus 360, I would still be at negative 170 degrees. So negative 170 is coterminal, but it's still not positive. So what am I going to need to do? I'm going to need to add 360 degrees to that again. So negative 170 plus 360 is 190 degrees. I'm now positive. That's the smallest positive angle. I could keep adding 360 and get bigger and bigger, but that's not going to give me the smallest one. All right, number 7, state the smallest positive angle in radians that is coterminal with 18 pi over 7. Well, a lot of times in radians, I'd rather think of this as a mixed number because I know just like I could add and subtract 360, I could add and subtract 2 pi. So what is 18 pi over 7? Well, 7 goes into 18 2 times. Whoa, 7 times 2 is not 16. 7 times 2 is 14. So 18 minus 14 is 4. So that means if I wanted to write this as a mixed number, this would be 2 4/7 of a pi. So if I subtract 2 4/7 of a pi, I can take away 2 pi from that because I could get smaller and still be positive, and that would give me just the 4/7 of a pi that I went over the 2 pi. Number 8, state a negative angle in radians that is coterminal with 18 pi over 7. Well, again, 18 pi over 7 was 2 4/7 of a pi. So in order to go negative, I would have to subtract 2 pi. I already did that up above, and when I subtracted 2 pi one time, it got me to 4 pi over 7, but now I'm going to have to subtract 2 pi again. Okay, I don't like to subtract a fraction from a whole number, so maybe we could rethink, and instead of 2 pi, if I need to think of that in terms of sevens, it would be 14/7. So if I do 4/7 minus 14/7, that would be negative 10/7 of a pi. All right, question 9 says to convert 130 degrees into radians. Leave your answer in simplest forms in terms of pi. So I have 130 degrees. The way I convert is to multiply by 1 in a useful form. So I need a useful relationship between degrees and radians. Well, what do I know? If I think of my basic unit circle right here, I know that 180 degrees was pi radians. So to me, that's the easiest fraction to use. In this case, I need to put my 180 degrees on the bottom so that these degrees can reduce out. And that means I'll need to put my pi radians up here on the top so that my answer will have radians left. Now I just need to simplify the rest of the problem. I have 130 over 180. Well, if I divide each of those by 10, I am left with 13/18. I also still had the pi, and I know I normally have pi in my radians. I don't have to, but I normally do. And this simplifies. Turn the page. Number 10, we're converting negative 5 pi over 18. So again, I've got to multiply by 1 in a useful form. In this case, I need to get rid of the radians, so I want to put my pi radians down here on the bottom of the fraction, and I'm going to put my 180 degrees up on the top of the fraction. This way, remember when I don't put units, it means radians, but my radians would reduce out, and my final answer would be in degrees. So I need to now reduce the numbers. I've got a negative, that's not going anywhere, so I'm going to write that down before I forget it. What can I reduce out of this thing? Well, my easiest thing I see to reduce is 18 goes into 180 10 times. Then I have a nice multiplication. I have pi and pi. Those are going to reduce out. So I now have negative 5 times 10, which is negative 50. And my final answer is negative 50 degrees. All right, number 11 asks me to find the complement and the supplement of pi over 7. So let's remember what these are. Complementary angles are angles who add to 90 degrees, or if we're in radians, instead of 90 degrees, that would be pi over 2. And supplements are angles that add to 180 degrees, or if we're in radians, that would be pi. So I'm going to do the supplement first because I think this looks much easier. What angle do I have? I have pi over 7. Well, pi over 7 is right here. That's a 7th of a pi. So if I have a 7th of a pi, then to make my supplement, how much do I have left to get to pi? Well, I would have 6/7 more to go to get to a whole pi. So my supplement is 6 pi over 7. I could also do that by subtracting. If I did pi minus pi over 7, that would give me 6 pi over 7. All right, let's go to my complement. Sorry. Again, I have pi over 7 in here. That's how far I've gone so far. Now I need to figure out how much do I need to go to get to pi over 2. Well, pi over 2 and pi over 7 are not units that like to relate to each other. So I think I would rather get a common denominator here. And my common denominator would be 14ths. So my pi over 7 would be 2 pi over 14, and my pi over 2 would be 7 pi over 14. So how much more do I need to go to get from 2/14 to 7/14? I need to go 5/14. That's the same thing as doing a subtraction. Okay, on number 12, Mark says that theta is 12 pi over 5, and beta, which is 6 pi over 5, have the same reference angles. Is he correct? Justify. It helps me to visualize these. So I make a little axis there, and I'm going to think, what is theta? I don't like to think of these big amounts in terms of improper fractions. I'd rather think of it of a mixed number. Well, 12/5 is 2 2/5 of a pi. So if I'm going to draw that, where will it put me? Starting in standard position, 2 pi is going all the way around, and then 2/5 is going to be over here. My reference angle would be 2 pi over 5. So theta reference is equal to 2 pi over 5. Next, I want to figure out where beta is. Beta is 6 pi over 5. Well, that means that beta 6/5 is 1 1/5. So where does that put me? 1 pi would bring me down here to the x-axis again, and then I'm going to go 1/5 over. So I've only gone 1/5 over, and, whoops, not beta, beta reference is equal to 1 pi over 5. So are these part of the same family rectangle? No, they do not have the same reference angles. So there, I wrote that down to answer the question. No, they do not have the same reference angles, and my work there is my justification. All right, question number 13 says, give an angle in each quadrant that has a reference angle of 47 degrees. Well, let's just start with 47. 47 is its own reference angle. So in quadrant 1, I could either give 47 degrees, or if I wanted to, I could give a coterminal angle with 47 degrees, and I could go all the way around and do 360 plus 47, which would be 407 degrees. So either one of those would work in the first quadrant. Okay, let's try something in the second quadrant. In the second quadrant, in order to have a reference angle of 47 degrees, my second quadrant angle I would be looking at is how much did I go in the positive direction to get to that terminal side right there. So that would be 180 minus 47, which would be 133 degrees. Okay, I think I need to draw a new picture over here. Let's go over into the third quadrant. If I'm going to land in the third quadrant, my reference angle would have to be right here to be a reference angle of 47 degrees. My original angle would have to be 180 plus 47 degrees, which would be 227 degrees. And then the easiest angle to me that I could give over in the fourth quadrant would just be to say, if I want my reference angle to be a positive 47 degrees, What if I had just gone the other direction and my reference angle would have been negative 47 degrees? You also could have done 360 minus 47, which would be 313 degrees. So there we go. There's infinitely many correct answers for this question, so I just gave a few. Okay, question 14. The terminal side of theta in standard position contains the point negative 8/17, comma 15/17. State the coordinates of the point on the terminal side of an angle that measures 720 minus theta. So that's a lot. Let's start out. Make a unit circle right here, and let's put this point on there. Sorry, they're drilling in the wall next door now. If you hear that, I apologize. All right, if I were in the unit circle and I wanted to go negative 8/17 in my x direction, I would be over here on the left. Positive 15/17 would put me up in the air, and I'd be somewhere in this ballpark. I'm not sure if I'm exactly on the unit circle, but wait a minute, I am, because 8, 15, 17 is a special right triangle. So here's my point on the terminal side. Now I know that we have a family rectangle here, and all of these points would have the same reference angle. If this is theta, and I need to find a point on the terminal side of an angle that measures 720 degrees minus theta. So let's see where that's going to put me. 720 degrees means I start out and I spin around 2 times and I'm back where I started. Now I need to go minus theta. Well, if theta was this amount up here, then minus theta is going to be this amount down here, and that's going to put me down here, which will have a coordinate where the x value is negative and the y value is also negative. But the key is they have the same numerical amount, just both locations are negative now. All right, number 15 says, is the point negative 3/4, 1/4 on the unit circle justify? Well, let's draw our unit circle right here. And let's say, where would this point land approximately? If I go negative 3/4, that's about 3/4 of the way to the left, and up 1/4. So the question is my point here going to land on the unit circle? Well, how could I figure that out? Well, in order to land on the unit circle, the radius has to be 1. So, does this work? Is negative 3/4 squared plus 1/4 squared equal to 1? Well, negative 3/4 squared, a negative times a negative is a positive. 3 squared is 3, 4 squared is 16. I'm sorry, 3 squared is 9, I wrote the right thing. 1/4 squared, 1 squared is 1. 4 squared is 16. So 9/16 plus 1/16 is 10/16. 10/16 is not equal to 1. So the answer is no, it is not on the unit circle because the hypotenuse does not equal 1. All right, number 16. If theta is an angle in standard position and the cosine of theta is less than 0, what does that mean? That means the cosine of theta is negative. Also, we have the tangent of theta is greater than 0. What does that mean? That means the tangent of theta is positive. So it says, then the terminal side of theta lies in which quadrant? Well, let's see where these two things can happen. The cosine. The cosine is the adjacent over the hypotenuse. If we want the cosine to be negative, we need to go over here on the left side, and the cosine is negative in quadrants 2 and 3. Now we have the tangent. The tangent is the opposite, which goes up, over the adjacent. So if both of those are positive, then the tangent is positive. Or if both of those are negative, then the tangent is negative. So the tangent is positive in quadrant 1 and 3. If we have an and situation, both things have to be true. Where were both things true? Over there in quadrant 3. I'd recommend you draw a picture on these because a lot of times you guys know where it is, but don't call it the right number. Remember, our quadrants are numbered 1, 2, 3, 4. Okay. Let's turn the page again for number 17. So we have the cosine of theta is equal to 0.2. So what does that mean? The cosine of theta is equal to 0.2, and I'm supposed to find the value of the cosine of 8 pi minus theta. Well, let me just draw a random triangle here. If my cosine is equal to 0.2, you might want to call 0.2 4/5. You might want to call 0.2 2/10. However you want to think of it. In essence, the adjacent would be 2 and the opposite would be 10. So here is an example of a theta. Doesn't really matter where we put it. I don't know what theta is, but if I'm trying to find the cosine of 8 pi minus theta, where's that going to put me? Well, 2 pi would be right here. 4 pi, 6 pi, 8 pi. So the 8 pi didn't do anything to me. All that really matters is the minus theta, which would put me down here. Well, what's my cosine of that triangle? What happened to my adjacent? Nothing. It's still positive 2. My hypotenuse is still positive 10, because my hypotenuse is always positive. So my cosine is still the same 0.2 it used to be. I just have to watch out on this one. If my triangle wound up flip over on the left, then my cosine would have been negative 0.2 instead. All right, number 18 says, which of the 6 trigonometric functions are not defined for 270 degrees? Well, 270 degrees is down here. So what would happen? What is not defined at 270 degrees? The coordinate of that point would be over 0, down 1, which means I cannot have x on the bottom of a fraction, because that would give me division by 0, which means I cannot have x is the adjacent side. So any of my trig ratios where the adjacent is the bottom of a fraction are going to be undefined. So I wrote down SOHCAHTOA there. In sine, the hypotenuse is on the bottom, so it's always defined. In cosine, the hypotenuse is on the bottom, so it's always defined. Tangent is the opposite over the adjacent. So the adjacent would be on the bottom of the fraction, and the tangent is going to be undefined. Now, let's also look at the reciprocals. If I had flipped over the sine, I would have hypotenuse over opposite. That doesn't involve the adjacent. If I flip over the cosine, I have the hypotenuse over the adjacent. That would be the secant. So my secant is also going to be undefined. If I flip over the tangent to get the adjacent over the opposite, that's going to be fine because now the 0 is on the top. So just the secant and the tangent are undefined for 270. Number 19, find the exact simplified value of the secant of alpha if the cotangent of alpha is negative 4 and the terminal side of alpha in standard position lies in the second quadrant. So let's start out by drawing a picture right here. Alpha is in standard position and my terminal side of alpha lies in the second quadrant. So alpha would be something like this. Again, I'm not going to worry about putting alpha in the triangle. I'm going to worry about this little reference triangle over here. That's what I'm thinking of. So the cotangent of alpha is negative 4. Well, all of my trig ratios are ratios. So as a fraction, I'm going to think of that as negative 4 over 1. Remember, that could be negative 4 over positive 1, or it could be positive 4 over negative 1. I'm going to have to think about what's going on in my situation. Cotangent is the reciprocal of the tangent. So instead of being opposite over adjacent, cotangent was adjacent over opposite. In my picture, my adjacent is my 4, my opposite is my 1, and since the adjacent is going to the left, that means the negative was on the top of the fraction with the negative 4. All right, now it's asking me to find the secant of alpha from this triangle. In order to find the secant of alpha, the secant is the reciprocal of the cosine, so that would be the hypotenuse over the adjacent. Well, I know that my adjacent is negative 4 because I just found that in my picture. I don't know what my hypotenuse is right now. I've got to find the hypotenuse. I can find that by doing the Pythagorean Theorem. So I have 1 squared plus negative 4 squared is h squared. So negative times a negative is a positive. So my hypotenuse would be the square root of 17. Again, I don't have to worry about the hypotenuse ever being negative, and I can't simplify the square root of 17. So I'm just going to put that right on top, and I have the secant of alpha is equal to the square root of 17 over negative 4. Doesn't matter if I put the negative out in front or on the bottom there, same thing. It's already simplified, so I'm good. Okay, question 20. Given the point P, which is at coordinates 2, negative 3, is on the terminal side of an angle theta in standard position, draw a diagram and find an exact simplified form. So let's start out and draw a diagram. So P is over 2 and down 3. And there's my point P at 2, negative 3. It said that P was on the terminal side of an angle theta in standard position. So that means that theta be somewhere in here. I'm supposed to find in exact simplified form OP, which remember when I don't put the line over the top means the length of OP or the distance from the origin to P, the length of the hypotenuse of that triangle. So let me draw some sides in here. The direction I've gone down was the negative 3, and the direction I've gone across was positive 2. So if I'm trying to find OP, I'm going to use my Pythagorean theorem. And OP squared would be 2 squared plus negative 3 squared. So OP squared, 2 times 2 is 4, negative 3 times negative 3 is positive 9. OP squared is 13. So OP could be plus or minus 13, but, square root of 13, I only need the positive because the hypotenuse is always positive. It's a distance. And that's the square root of 13. So let me draw that into my triangle. Square root of 13. Now I'm trying to find my trig ratios. The sine of theta is the opposite, which was negative 3, over the hypotenuse, which was the square root of 13. I can't leave my answer like that. I need to rationalize my denominator. So I'm going to multiply by the square root of 13 on the top and bottom, and I'll have negative 3 square root of 13 over 13. All right, how about the cosine? Well, the cosine is the adjacent, which was 2, over the hypotenuse, which was the square root of 13. Again, I can't leave that with a square root of 13 on the bottom, so I'm going to rationalize by multiplying by the square root of 13 over the square root of 13, and I'll have 2 square roots of 13 over 13. This one is positive since the 2 was positive. The tangent of theta is the opposite, which was negative 3, over the adjacent, which was positive 2, and that's done, nice and simplified. All right, now in the second column here, I'm on the reciprocal functions. The cosecant is the reciprocal of the sine. Rather than flip my rationalized answer, it's easier for me to go back and flip the answer that was unrationalized. So the cosecant is the hypotenuse, which was the square root of 13, over the opposite, which was negative 3, and now my answer is already in simplified form. The secant is the flip of the cosine. So now the adjacent is on the bottom, and the hypotenuse is on the top. And the secant is the square root of 13 over 2. The cotangent flips the tangent. So the cotangent is now the adjacent over the opposite, or 2 over negative 3. All right, last page here. On these, we're supposed to find the exact simplified value using our special right triangles and our knowledge of the unit circle. So question A asks me for the sine of 510 degrees. So the first thing I like to do in all of these questions is to sketch myself a little picture. If I make 510 in standard degrees, I would go all the way around and then I go some more. So I need to figure out how much more over 360 do I go. So I'm going to do 510 minus 360, and that is 150 degrees. So I'm going to keep going all the way over here. That means that what I have left is 30 degrees, and this is a 30, 60, 90 triangle. I know the ratio of the sides of a 30, 60, 90 triangle are 1, square root of 3, and 2. If I put them in the unit circle, that means the short side of my triangle is 1/2, the long side of my triangle is square root of 3 over 2, and that way the hypotenuse can be 1 and it can be part of a unit circle. I also need to be careful that any values to the left or down are made negative. For the sine, all I need is the y value on the unit circle, because that's the opposite over the hypotenuse, and the answer to this question is 1/2. Question B, the tangent of 30 degrees. Again, I'm going to draw my reference triangle. This is a 30-degree reference angle, so the short side is 1/2, that goes up. The long side is the square root of 3 over 2, and that's the adjacent. The hypotenuse is always 1 in the unit circle. Tangent is the opposite, which is 1/2, over the adjacent, which is the square root of 3 over 2. So now I need to simplify this. My 2's can reduce out because they're both on the bottom, and now I have 1 over the square root of 3. This has to be rationalized by multiplying the top and bottom by the square root of 3, and my answer to the tangent of 30 degrees is the square root of 3 over 3. Question C asks for the tangent of 4 pi over 3. Well, if I'm thinking of where 4 pi over 3 lands, 4 pi over 3 is 1 1/3 of a pi. So that means I'm going 1 pi, and then an additional third would give me a pi over 3, or 60-degree reference angle down here. So again, it's the tangent, so I'm going to need the opposite over the adjacent. The opposite is the vertical side, which is across from the 60. This would be the big side, the square root of 3 over 2, and that needs to be negative because it's going down. The adjacent is the short side, which would be the 1/2, and it needs to be negative because it's going to the left. So the tangent is the opposite, which is negative square root of 3 over 2, over the adjacent, which was negative 1/2. Again, my 2's can reduce out, my negatives can reduce out, and my final answer is just the square root of 3. I'm going to do F, G, and H now since they're on the screen already. The cotangent of 5 pi over 4. Well, 5/4 is 1 1/4 of a pi. Sorry, my board's dying on me here. Let me see if I can get it back. So that means I need to go 1 pi, and an additional 1/4 of a pi would give me a pi over 4 reference angle, or a 45-degree reference angle. So the ratio of the sides of a 45-90 triangle is 1 square root of 2. Since I need my hypotenuse to be 1 in the unit circle, I call my opposite and my adjacent the square root of 2 over 2. This one's going to the left, or going down, so it's negative, and the adjacent side over here is going to the left, so it's negative. The cotangent is the adjacent over the opposite. In this case, it really doesn't matter since they're both the same thing. So I have negative square root of 2 over 2 over negative square root of 2 over 2, which we should realize just simplifies to plain old 1. All right, part G asks for the sine of 45 degrees. So this is a nice one right in the first quadrant. 45 degrees is its own reference angle. So the sides are the square root of 2 over 2, and the hypotenuse is 1 because we're in a unit circle. So the sine of 45 degrees is the square root of 2 over 2. The secant of 60 degrees. If I draw a 60-degree reference angle, then I know my short side is 1/2. I only need the short side because the secant is the reciprocal of the cosine. I know my hypotenuse is 1, so I didn't write that down. But the secant is 1 over the cosine of 60 degrees. So that's 1 over 1/2, which is 2. All right, let's scroll down to the bottom set here. In D, the sine of 5 pi over 3, well, 5/3 is 1 2/3 of a pi. So when I'm drawing, that means I go 1 2/3 of the way around. So I am 1/3, or 60 degrees short of going all the way around. I need the sine, which is the opposite, or the vertical piece here in the unit circle. That's the long side, so it's the square root of 3 over 2, and it's negative because it goes down. Again, my hypotenuse is 1, so the sine is negative square root of 3 over 2. the cosine of pi over 2. Well, if I go to try and draw a reference triangle, pi over 2 is right up here at the top. I'm going to put in a unit circle. I can't really draw a reference triangle for this one because my adjacent side is so small, it's 0. My opposite side is going straight up in the air and it's 1, so really the easiest thing for me to do is to use the coordinates of this point, which are 0, 1. Cosine is the x value on the unit circle, which is 0, and you can see the adjacent side of a triangle, in essence, would be 0 because we didn't go over at all. The secant of 180 degrees. Again, 180 degrees is a quadrantal angle. The coordinates of that point are -1, 0. If I were trying to draw a little reference triangle, I would have essentially no upward direction, which is why the y value there is 0. But my adjacent would be -1 because it's laying right there on the x-axis. The secant is the reciprocal of the cosine. So it's 1 over the x value on the unit circle, which was -1. 1 divided by -1 simplifies to -1. J is the cosecant of -pi over 3. So I need to go in the negative direction, so my angle is going to swing down like this. It's a pi over 3, which is a 60-degree reference angle. The cosecant is the reciprocal of the sine. So I need the y value, or the opposite side of this triangle. It's the long side, so it's the square root of 3 over 2. It's going down, so it's negative. My hypotenuse is still 1. So 1 over the sine is 1 over negative square root of 3 over 2. Or I could just flip my fraction there, since it's divided, and call it -2 over the square root of 3. I cannot leave the square root of 3 on the bottom of my fraction. To rationalize, I'll multiply by the square root of 3 on the top and the bottom. And my final answer is -2 square root of 3 over 3. All right, you got to know these basic triangles, and you got to be able to convert